Okay, so let's go through all of the steps for graphing this polynomial right here. Okay? So, just like in the previous problems, the first part of this problem is the critical points. Okay, so f prime of x is going to be 4x cubed minus 4x. Okay. So what can I pull out? I can pull 4x out of this problem. That's x squared minus 1. And we can factor that further as x plus 1 times x minus 1, which equals 0. Okay. So, what do we get from this? We get x, which equals 0, x, which equals negative 1, and x, which equals 1. Okay. So, the next question would be, max or min. So let's do the second derivative test on this one. So the second derivative of x with respect to x would be 12x squared minus 4. So So the second derivative at 0 is just going to equal negative 4. All right, now this is negative, meaning that it is concave downwards and flat at top. So that makes that guy max. Okay. Now f prime of negative 1, well, if it's 12x squared, negative 1 squared is just going to become a 1. So this becomes 12 minus 4, which is 8. Which is greater than 0. So that guy is a min. Okay. Now, also equals 8, which is greater than 0. So that guy is also a min. Okay, so we know what's max and what's min. And so the next question is, okay, what's the inflection point? Okay, so the inflection point so we simplify this, we get that x squared is going to equal 4 divided by 12, and that can be simplified as 1 divided by 3. Okay? And then we take the square root of both sides, and we're going to get that x is going to equal plus or minus the square root of 1 divided by 3. So this guy is actually going to have 2 inflection points. You're going to have more than one inflection point. I mean, if you think about sine of x or cosine of x, they've got infinitely many inflection points because it's just a wave that keeps changing from being positive to negative, positive concavity to negative, and back and forth forever. All right. So at that point, we can say, let's graph this thing. So remember, whenever you go to the graphing, go back to your original function. Okay. So f of 0 is kind of obvious, that one's 11. Okay, so that's 1 to the 4th minus 2, so that's negative 1. And negative 1 plus 11 is going to be 10. And f of negative 1 is also going to equal 10. Right? So, when graphing this thing, let's call this point 11, we'll call this point 10. So there'd be a max right there, and then right there, and then right there. Okay. And so that would be the graph of our function. Then we can ask the question, where is it increasing, where is it decreasing, and what is the concavity? So for increasing, this would be negative 1 to 0, and then union 1 to infinity. And for decreasing, that would be negative infinity up to negative 1, and then union 0 to 1. Oh, sorry. If you look at the graph, that should make sense. And when I do this on a test, if you look on the practice test, this one's on one. I actually give you a scale so that you can see this is 11, 9, 11, 10, 9, yada, yada, yada. And so if your graph does not fit onto the scale that I put on there, you have the wrong graph. Okay, then we can ask, where is this thing concave up and where is it down? Okay, so say, we'll start with up. All right, now remember, the concave up and concave down are always going to be associated with the inflection points, okay? So the inflection points are occurring right inside of here and right inside of here, okay? This is going to be negative 1 over the square root of 3, and this is going to be positive 1 over the square root of 3. So for up, this would be negative infinity to negative square root of 1 over 3. And square root of 1 over 3 to infinity, okay? And down would be negative square root of 1 over 3 all the way to square root of 1 over 3. Okay? So this thing is concave up in this region right here, then it switches to being concave down right here, and then it switches back to being concave up over there. And that's all the information that you would need for the test.